Yeah, so we'll start with talking about how we power the camera on.
Okay.
We're using an XLR adapter with a V-mount battery. We use these V-mount batteries because they provide a clean electrical signal to our camera, and they're ubiquitous. You can buy them pretty much anywhere in all sorts of capacities. Big ones so you can last all day, or smaller ones that'll be useful when you need to travel and get through TSA because they have limits on how many watt hours a battery can be. And then we're connected to our control interface. This is a Chromebook, but you can connect to with via Ethernet adapter to iPhone, iPad, Windows computer, MacBook, virtually any device that has a web browser. Then you just type in the IP address of the camera, and that's how you can control it from any device.
Okay.
So we have our preview window here, which gives us a sort of a low quality preview, just so you can make sure that you've got your exposure values correct and everything looks normal. Like, for example, when we turned it on this morning, we had forgot for previous demo that we had it set for manual exposure, so everything was all really bright white. So that's nice, so that you can verify that your image quality is going to be what you need it to be when you get back to the office. In the settings, you have a lot of options here, so you can do some manual EV correction. It's a pretty bright day out this morning since we're getting started, and the sun's still pretty low, so I'll have it set to negative 0.5. And then we have our triggering mode down here. So we're running it at every frame, every 5 meters, we're going to capture a frame.
Okay.
The camera is in free running mode, which means while we are not recording every frame at 10 FPS, the camera is still running at 10 FPS. And that's very useful for our auto exposure algorithm, because rather than every 5 meters, it's trying to figure out what its exposure value needs to be. It's constantly updating that value. So when you get to that 5 meter point, it's gonna be able to really easily, quickly calculate what that exposure value should be. We can go to status and see, just make sure some various information about how we're set up and our system time. Storage, we can see our previous reels. We can also check here to see all the other, you can see all the other demo drives I've done.
Wow.
Yeah, and you can make notes about the drives if you need to, and then you can also see sort of a breakdown of how we structure our data. So these are all non-proprietary data formats: GPX, TXT, CSV, JSON. So it's all non-proprietary. It's not encoded in any way that, so you can manipulate the data any way you please, and then you own it.
So where is the data being stored?
So the data is being stored internally on a SSD that looks just like this one.
Okay.
So there's a little black hand turn knob on the back of the camera, and you pull this out, and then you just plug it right into your computer. And this is a 1 terabyte drive, and they come up to sizes of 2 terabytes. So we'll go ahead and get the preview again. And if you want to start us off, you can go ahead and click that button in the middle for me.
Recording started.
And we're off. We have the auditory cues about when this recording is started, when it is stopped, as well as if you were to encounter an issue like a GPS denial. Maybe you went through a tunnel for a really long time. And that's really good for driver safety. You have people on the road. The less time they can be looking at the screen, the better.
Yeah.
In frames, or distance-based triggering mode, so it's showing us how many frames we recorded. Note that we're stopped at a stoplight right now, and we're not increasing that frame count.
Okay.
That's really important because when you go to process this data, you don't have a bunch of redundant frames that you need to then process. As well as for data storage, you're not storing a bunch of redundant data, because we could sit here for a minute and record a ton of frames.
Yeah. So how is it calculating every 5 meters? Do you have anything connected to the wheel, or is it just by GPS?
Just by GPS, yeah. What's great about this camera is, so note we're stopped at a stoplight. We've got 40 frames. I'm going to disconnect our control device with this USB adapter. So our camera's going to show us offline here in a moment. And then we're just going to keep on driving. When we get to this next slide, I'll plug it back in. So I'm gonna plug it back in. Wait for it to recognize the Ethernet cable. And what we're gonna notice is that we were at 40 frames. And soon we'll be now we're at 84 frames.
Okay, so it was still
It's still capturing it regardless if the control device is disconnected, which is really useful if, for example, you forgot to charge your phone or tablet and the battery dies on your control device. You can know that the camera is still running, still capturing data, and you're not going to have to worry about, did I miss something?
Yeah.
Some other cameras, when the control device is disconnected, then the capture will stop. And so that's one of the usability things we really like about this.
Are these pictures being saved somehow to this, in a less quality somehow? Yeah, I was just thinking, the safe, where I work, it's all security, and we cannot even have anything connected to the scanners. It's all,
Well, the data is only being streamed. There's none of these frames are being saved to the hard drive or storage on this device. In fact, if that were the case, this little Chromebook would have been overloaded days ago.
Yeah.
Important, and yeah, you definitely want to make sure you're meeting your client's requirements. So
yeah. Have you combined this with a scanner mounted on with your technique?
Yeah, with LiDAR scanners, integrations with Riegl, as well as recently with Leica. We're able to sync up the timestamps on that data for the Leica TRK. And then customers have also used other LiDAR scanners like Hesai and ZNF with their Mosaic cameras. So you can tie all that data together, colorize a point cloud if you need to. You can also use higher precision IMU and GPS receivers. For example, like an XVN that has like a dual RTK antennas, so you can get sub-meter or sub-centimeter precision in where you are. And also provide some important information about your pitch, roll, yaw.
Images.
So you can see we've recorded 600 frames here, and each of those video containers is going to give you a live preview of how many megabytes or gigabytes you're going to be looking at right here.
What does it mean?
So that means that's
the accuracy of just the...
yeah.